Good afternoon. I'm John Mailhot from Imagine Communications, and my colleague Gareth Wills from Imagine Communications, and we're here to talk about cloud-based workflows and what is the cloud really good for. So take it away, Gareth.
So there is a well-known joke about the cloud, and so the cloud is not some magic thing in the sky that's going to solve all your problems. Some of you may even have this T-shirt, but the one okay, this is a well-known joke about the cloud. Some of you may already have the T-shirt, um, but in case you didn't know, it's not some magic thing that exists. It's just someone else's computer, and that someone has packaged a whole pile of useful services to make it easier for you to basically spend money. So what is the cloud for this discussion? So the cloud is basically compute resources by the minute, by the hour, by the day, and various capabilities. And there might be different resources, different CPUs, different memory configurations, different storage resources, and that's often charged by the gigabit per month. You can have various different bandwidth capabilities on your storage. And there's obviously the network resources and the ingress and the egress that comes with that as well. Most of the egress is measured, obviously billed as egress only rather than ingress. But then there's also special rates for services. And these services are designed to make it easy for you to deploy complex applications. These are things like managed Kubernetes clusters, databases, load balancing, message queues. And these services exist generally just to make your life a lot easier.
Now, are the same services available no matter which cloud I use?
Most cloud providers have the same services. So,
But like the same, or just kind of similar?
similar. So if you look at EKS, that's the Elastic Kubernetes service in AWS. That's exactly the same as GKS. So it's the same underlying Kubernetes engine, just sort of wrapped in their cloud flavor. And then on top of these special services, we have software applications. These can be pay-as-you-go applications for the minute, billed by the minute, by the hour, by the day. These are effectively templated images that can be really handy for rapidly prototyping things like SRT. For example, if you want an SRT receiver, you can go into the marketplace, you can buy one, you can use it, and really handy way of rapidly prototyping and getting something to market really quickly. The one thing you have to remember is that everything is metered and billed, and usually after the fact. So it's like going into a McDonald's and getting a milkshake, and you've got to buy the cup, you've got to buy the milk, you've got to buy the flavoring, you've got to buy the straw. Getting some French fries, you've got to buy the packaging, and everything is billed at a very granular level. And often you only know the costs after the fact. So it's really critical when you design cloud systems that you actually design it in a way that you're, for example, if you have to change an instance size or you change some bandwidth parameters or some stream that's coming in, that can often impact your overall costing. So it's really important in the design phase to get as much detail as you can.
Okay. And are people ever surprised that it costs less than they expected?
So there are really handy tools available for cost calculations. So AWS have their calculator. There's similar for Azure and Google. Usually you can get around plus or minus a couple of % using these cost calculators. So there often is no surprises, but there can be, like I say, if someone changes an instance size, or maybe they might change the bandwidth coming in for a certain live feed. That can all change.
Now, what about on-prem?
So for on-prem for this discussion, we're talking about incremental computers that you buy. So that might be Dell, it might be HP, whatever your favorite flavor of hardware is. And obviously this is the incremental storage that you buy, so the spinning disks you put in order to connect to those computers. And then you've got incremental networking you buy. So these are the switches, the GigE, Ethernet connectors, and then there's the support costs on top of that, and then the incremental power and the HVAC and the support. And all of these on-prem costs are relatively easy to compute. You know how much a server is going to buy, you know how much a disk costs you, and you roughly know how much you pay for power and HVAC. But there are some costs that aren't so easy, and that's kind of the share of cost and rent, the net present value of your capital, whether you want to go CapEx, whether you want to go OpEx, and there's obviously the risk of having stranded assets on your books in terms of, if you buy a server for a specific task and you don't utilize that server, then there's that risk of that stranded asset.
So this would make comparing it all really hard.
It is very hard.
But then it gets worse.
It gets worse. So there's real intangible factors, and here's a collection of comments that we often hear from various customers and people we've talked to. The first one is, if my team installs and manages and controls it, it'll get fixed quickly. I.e., if I have control, I can go down to the rack room and I can yell at my broadcast engineer and I can get it fixed. That's generally, I want control over my systems, and I want to know that I have complete control. But then there's the other flip side that says, well, if I go into the cloud, what if the whole data center goes down? Where am I in line? Well, the honest answer to that is you're in line with everyone else, because most of the services that exist in the cloud aren't snowflakes. So for example, if the messaging service or the load balancing service has issues, it's likely the same service that Home Depot use, for example. So sometimes having the big fish play in the same pond is often helpful for you to actually get these issues addressed. Then there's the question of, what if my building becomes unavailable? If there's a catastrophic failure, a flood, or even a pandemic when I can't get to it, this is where the cloud really comes into it. And there's a couple of slides later on where we talk about the benefits of collaboration, having that remote access, being able to access it from anywhere, being able to scale, without having necessarily access to your brick and mortar. And then there's how do I get signals in? How reliable are these signals? How do I switch these signals within a fabric within the cloud? Does it look and feel like a standard on-premise router?
Yep. Now, what about, customers think about putting stuff in the cloud, but we also hear about, if I take this one piece and put it in the cloud, well, I really don't save anything because I still have to have a machine room and a team and stand it up and use it. So is that, I guess if you can drive your facility all the way to zero, maybe there's an interesting benefit.
But you look at the limit, that's a limitation of saying I want to migrate everything to the cloud, but you don't have to migrate everything to the cloud. And I'd sort of counter that statement by saying that even if you move 10% of your workflows to the cloud, there's still benefits of cloud adoption beyond still having that on-prem footprint, right? So you can't, there may not necessarily be immediate cost savings, but there's benefits such as scalability, flexibility, and the resilience you can get from the cloud. And also, like I said earlier, is access and remote access and being able to collaborate, in different parts of the world in terms of on the same technical solution.
Okay. Now, sometimes you just can't escape being there, right? I mean, that's
Yes.
especially with EAS, where it's a local receiver and it's got to be in your market because it has to get the signal from the police department.
Yeah, and there's going to be things for regulatory requirements and operational reasons that they just have to be on your site. So the key there is to how do we start to move some of that capability, such as EAS, into the cloud, and then things like ground stations. How do we get those feeds into and out of the cloud reliably?
Mm-hmm. All right. So I hear about utilization. Tell me about utilization.
So utilization matters when you start looking at the costs between the cloud and on-prem. So for example, let's look at an edit suite, that maybe just be used for pres editing, may be used for marking and trimming content. That edit suite may only be used for 6 hours a day, which is around about 36 hours in a week, which is about 21% utilization. So you can look at that and you can say, well, should I move that to the cloud? Should I move it to on-prem? But there's one intangible here, and that is that, once you put that in the cloud, it makes the suite become accessible anywhere. So for example, if you've got multiple stations, spread across the US, they could potentially share that same resource, right? So you don't have to duplicate that resource across multiple locations. So these are all considerations you have to sort of include when you look at that whole total cost of ownership. Another example is 24/7 playout. That's running full time, 100% utilization. Does it make sense to move that to the cloud? But there's an intangible there and says, well, I still have to have a redundancy capability. I either have to build another on-premise facility, or then I can leverage the cloud in terms of bursting out into for DR capability.
Or you could run 100% in two different AZs in the cloud,
Correct.
or two different, data centers even.
Or you could look at how you do your redundancy and saying, okay, I'm going to have, if you already have two facilities, it's like I'm going to take the 100% utilized full buckles and suspenders on-prem solution, split it between the two sites, and then you've got natural sort of geodiversity at the DR level as well. Then the other example is, backing up an on-prem channel. So you might just have a training system that you might use, might be 6% utilized, over a cost of time. That could also be moved to the cloud as well. Being able to there might be some concerns around content management and content movement, but some of these low utilized sort of training facilities is also a great space to leverage the cloud capability.
Yeah, one of my favorite questions to ask customers when I visit them is, what's your DR strategy? And they'll have one, right? And then the second question is, how often do you rehearse it? Like, do you actually run that way, and when? And that's always interesting. So best practice seems to be that maybe one night a week that you really run on your DR, and everything has to work and the ads count and it's like it's real. If you don't do it at least that often, then you don't have the operational readiness. People are suddenly scrambling to find the book and figure out how to do it.
I think I've got a point just on that fact
Yes.
later on. The other example is linked list and regional splits, right? Why do we have servers that are just there doing regionalization for maybe a couple of hours during prime time? They might be utilized, let's say 12.5%. Is there a better way of being able to bolt on those additional services and these additional regional splits at specific times in terms of maximizing their utilization? And again, this is where we can burst into the cloud for this sort of capability. So what is the magic of balancing utilizations? You've heard us talk about, being able to take these low utilized systems like training systems, like regional splits, and then these high utilization systems like these on-prem playout facilities. How do we balance that? So we did an exercise and we said the cost of an on-prem solution, an HPE server, 32 cores, some boot drives, some memory, about $12,000. You add a little bit of internal storage.
And that's list, but nobody pays list.
Yeah, exactly. And then you got dual Ethernet adapters, power consumption, cooling, and we calculated that roughly around about $16,750 a year.
Yeah, that's U.S. East Coast cost of power. Maybe it's different in different countries.
Yeah, so that's 3 years, 16,000 for 3 years. Looking at the same capability in AWS, an M7 8XL, and we could play around with the instance sizes a little bit, but roughly the same.
Well, I picked that one just because it matches the computer. But
again, $16,000 a year, a little bit of storage, a little bit of networking. That obviously will fluctuate depending on what you're actually going to use the server for. So it's difficult to get a full cost on that. But roughly, we're at about $17,750 a year for a cloud channel. So that the cost parity in that is roughly around 30% utilization.
Mm-hmm. Yep, which, funny enough, is a similar metric to leasing a car or certain other things in your life. If you look at leasing versus buying, there's a, not too different number. But it was interesting. I had never done this exercise with real numbers. And, in each case, most people have some agreement where maybe they don't pay list for the computers. Also, these are the list prices for AWS. But typically people sign corporate agreements. But, you have to do the math, and the math is doable.
Yeah, in AWS, there's different ways of say, this is obviously list, but you can do reserved instance. There's different ways you can save there. But also there's as John said, these are HP list prices as well. So there's obviously room to move on those as well.
Whoops, that was totally not what I meant to do. Okay, sorry. I failed my driving test. Now, interestingly, utilization is also an issue on-prem. It's just the opposite issue, right? You buy equipment, and if you don't use it, it's still sitting there, it's still burning power, you're still paying for it. And we've been managing that way for years, so that's the normal we know. But if you think about a TV facility, maybe with some regional splits, yeah, you know, a couple hours a day, you run those splits. Well, those servers are sitting there running 24/7, even if they're all doing the same list, which is really ridiculous, but we've done it for so long that
and
we're
not
used
good
to
for
it.
your carbon footprint.
Well, yeah, there's a whole set of examples there. Now, that said, you know, TV facilities historically are always designed for the worst case. They're designed for what you're going to do on that one college basketball Saturday when you need all 17 threads of the broadcast facility, right? And this isn't sensible. It's not financially sustainable. It's not environmentally sustainable. And yet we've always done it. But, you know, there are a lot of things you could do that you don't do today because you'd have to build up another chain and you're like, well, I'm only going to use that one 10%. So that's the other way you have to look at this, is not just what's the utilization, but also what are the things that I don't even bother to do because the utilization wouldn't be there to support it on-prem. But if you have a mixed cloud environment, now you could do those things easily.
We want to go through a couple of examples of that. So let's look at on-prem with DR. So you've got your on-prem facility and we're going to use cloud for DR. What are the benefits here? Well, you can use the on-prem cost advantage that you have. So that whole calculation of HP of the servers, you can run it at 100% utilization, but obviously be environmentally conscious at the same time. But then you can take cloud DR resources and use them cost effectively. So think about using cold resources, right? So think about having them provisioned, but running in idle, and that's going to lower your costs, right? But remember also the complexity of having something that's cold and being able to synchronize those playlists from on-prem into the cloud. There's obviously operational nuances there that have to be considered. So, you know, use the cloud, use cloud scalably as well. When I was doing DR as an operator, I used to send tapes down to our DR facility, and we had 8 hours of tapes. And I'd say, well, what happens after 8 hours? And they'd say, oh, we'll figure it out. You know, we'll get someone on planes. We'll do that. But maybe you might not be able to get someone on a plane, right? So once you've got that thin DR strategy, that can then be scaled out, right? So in other words, you know, you could have some of that resource not, you know, provisioned but not being used, spin it up when it's needed, and then if you're going to be in a DR scenario for a longer period of time, then you can scale it out using that sort of infinite cloud capability.
Yeah, I think early on we had a client that we were doing a cloud DR proof of concept with, and we had the traffic integration, everything kind of working. And, you know, the proof of concept was going pretty well, and they actually had a real calamity in their main facility, and they ran off that cloud DR for like days and days.
Yeah.
And it was the best proof of concept ever because it really worked, and it really worked when they needed it to.
Yeah. And the key message here is to be smart with design, and the cost that it's going to be to run a cloud DR or to run anything in the cloud is going to be proportional to your caution level or your paranoia. So you know, think about that when you do your cloud designs. But think about provisioning the essential resources that you can switch on quickly, i.e. you can have evergreen content that's switchable really quickly, and then you can bring up that standby capacity and pay the cloud invoice when needed. And the last bullet point is to John's point earlier, is test it frequently. Because the number of times I've gone into a facility and they've switched to DR and the DR doesn't work because Jeff didn't append the schedule. Test it frequently and test it you know, once every month or something to make sure that you can switch to a DR, you know, if necessary.
Yep.
Another example is, you know, short-term capacity. And I used the Olympics as an example, but I was thinking about this last night, and it's the same as what we're doing at NAB, right? We ship we have a whole pile of demos, we have a whole pile of equipment. You know, how do we build a television station in the short term, and how do we generate that 100% utilization for a short period of time? And what the cloud is what the benefits we get from cloud there is we don't have to ship. We've got a whole demo system over there that we didn't ship. We didn't pay any money to FedEx to get any equipment here. There were no delivery lead times. We didn't have to rack and stack, and we didn't have to put any networking in. Well, maybe we did put a little bit of networking in, but But basically, we're leveraging that whole pay-per-use scalability. And then once it's done, we're going to tear it down, and we're not left with any stranded assets. And basically, the cloud resources match precisely to the level of utilization that we need. And also, when we were building the system, like I said earlier, don't underestimate the cost savings of being able to remotely access these systems and to be able to collaborate and use it remotely, right? Like the systems that we use are accessible globally. And you know, we don't have to put people on planes. There's a lot of cost savings that you need to factor in.
You're saying you built the demo from your house in New Zealand?
I did.
Yes.
I did. And I collaborated with someone in Cincinnati who also accesses the same environment. So, you know, these are all benefits. And also, you know, if we've got the system, let's say you want to generate, I don't know, 5 channels for the Olympics, putting those in the cloud, the chances of those actual live feeds from the games being in the cloud are quite strong, right? You've also got access to all the endpoints, all the CDNs for that OTT delivery. So it also brings a lot of benefits in that sense that you don't have to, you can leverage them and not have to bring that down to the ground.
Okay, great. Now what about regional splitting? We keep talking about that. Oops.
Yeah, so this is an interesting one. So, you know, we talked about regional splits and we said, you know, you roughly get 12% utilization if you buy an on-prem server. They spin there, they use power. Just not very environmentally friendly to have those servers there. But what say that you could spin up these resources dynamically, right? So you could have a network channel that at prime time on a Friday night, we spun up another channel, we hooked into that channel, and we augmented our on-prem by having this other cloud-based system dynamically join the playlist for a period of time. It might only do a couple of commercial insertions in that night, but we can spin it up, we can do those insertions, and we can tear it down. So what this is going to bring is, you know, increased revenue opportunity in terms of being able to reach those regions that you previously might not have been economically viable, and maybe even being able to offer those sorts of regional capabilities there might grow other regions in terms of being able to offer that support as well.
Right. If you're not tuned into the dynamics of television advertising, you may not realize that if you drive to the other end of your town and watch the same channel, you may see different ads. And this ability to split, even in a local area, is quite significant for the advertiser. They can target this side, that side. They can target different demographics, maybe for different parts of town. They can target different delivery methods. But right now, every one of those split opportunities is colored by the cost of executing it. And so one of the things that cloud really does well is to reduce the incremental cost of executing these kinds of splits. So we think that's going to create a whole new set of opportunities for regionalization of content because we're changing the cost paradigm for how that regionalization works.
But with opportunity also comes challenges. So, you know, there's some things we've got to think about is how do you manage the latency of getting those feeds into the cloud, and there's latencies against the main channel versus the regional splits, and also how do you manage switching in and out of those channels? In other words, you know, from an automation perspective, how do I say this market here is taking this feed now and then it switches back? These are all solvable, but there are challenges that we've got to think about when we go into the design of these sorts of solutions.
Right. So just to wrap up a little bit, you know, cloud hosting maybe 4 or 5 years ago, if you listen to a talk like this, it would be about, can this work? Is this technically possible? Is it technically feasible? I think that's all been proven. Yeah, people are running television in the cloud every day. Now the question is really about optimization. How do we use the cloud in a way that creates cost advantage, that creates efficiency of operations? You know, 100% utilization, yeah, the math works better on-prem. But there's a lot of things that we do that are nowhere near 100% utilization. And those are the workloads that we need to look at. How do we do that in the cloud and keep the right balance of risk and everything else? And then, of course, it's all about these operational considerations. This is all science until it meets operations, where real operators on real Tuesday nights have to actually do it. And that's where, as an industry, you know, the next battle is how do we automate, how do we orchestrate these kinds of workflows? And these operational considerations are ultimately what drives the bus in many television environments. Is, can we really do it? Can we really do it repeatably with a good air product at the end of the day?
Yeah, we shouldn't underestimate the importance of operations and the success of all of these techniques that we've talked about.
All right, but anyway, thank you for coming by today, and we look forward to seeing you around the show floor. At your out point, if you have any questions. If you have any questions, I'm happy to hear them.
Anybody with questions? Any questions? Okay, hold on.
He's a known heckler. Be careful.
We love known hecklers.
So how bulletproof are the data centers that you're putting your DR into?
Pretty bulletproof.
Yep. I was going to say they're better protected and better armored and better fenced than your facility probably is.
Yes.
Internally they have a lot of redundancy, but they're like any facility. I mean, if something really bad happened, sure. I mean, that's any facility could have a total outage, but it's quite rare. And I think that each of the cloud providers would be happy to tell you how they make sure that doesn't happen.
Yeah, each of it. If we look at AWS, for example, each region has multiple availability zones. So US East 1, I think, has 6 availability zones, and each one of those availability zones is actually a building with a fence, with its own air conditioning, with its own power supply. So the chances of you losing the entire region is slim. And if you need to design correctly in terms of splitting your resources across those availability zones, in terms of making it 100% bulletproof. But as John said, it is a lot more bulletproof than most data centers out there.
Okay, thank you very much, gentlemen.
Thank you.
Okay.